Welcome students of 9th standard class. Welcome to Nisha Academy. I request all you students to stay home and stay healthy because the disease coronavirus does not allow us to wander outside. So we Nisha Academy are providing the video lecture series for you. Myself Rakesh, I am your physics teacher. Today we are starting the chapter 8, which is motion. This video is for class 9 GSEB and CBSE both. What is motion? Can you explain about the motion? Let us start learning what the motion and its different aspects. In our day-to-day life, we see some of the objects at rest and others are in motion. You can look around you and you find the different objects which are changing its position with respect to time. Like birds fly, fish will swim, blood in your body flows through your veins and arteries, and cars, buses, trucks, trains, planes, they are moving. We often perceive an object to be in motion when its position is changes with respect to time. You can find out the different objects around you which are changing the position. When you are traveling from one room to another, you are changing your position with respect to time. So you can say that you are in motion. But the table remains steady, so we can say that your table, chair, which is not moving. What causes the phenomena of sunrise, sunset and changing of seasons? It is due to the motion of earth. If it is true, then why we do not directly perceive the motion of earth? Can you guess? Because the size of the earth is very large with respect to the size of human beings. An object is appear to be moving for one person and stationary for some another. Why do so? For the passenger in a moving bus, the roadside tree appears to be moving backward, but for the person which is standing outside of the bus, the roadside trees are moving, remain stationary. Why it so? Because the reference position from which you are looking the trees, the passenger who is in the bus are in motion and find the trees moving backward, but the person who is at the outside of the bus and stationary, we find it, they also find the trees stationary. So in this chapter we'll first learn to describe the motion of the object, motion in straight line. We also learn to express such motions through the simple equations and graph, and later we shall discuss the ways of describing the circular motion. In this slide I had highlighted some of the letters, words highlighted in red fonts. Kindly make a focus on that. So what is motion? An object is said to be in motion if it changes its position with respect to its surroundings in given time, which is called the motion. Motion is always observed and measured with a point of reference. All living things shows motion, whereas non-living things shows motion only when some force acting on it. Let us see the types of motion. We can subdivide the motion in translatory motion and circular motion. What is translatory motion? The motion in which all the points of a moving body uniformly along a straight line is called a translatory motion. You can see in the picture the car and the bicycle both are moving in a straight line, so we can say that they are changing their position with respect to time. In the another figure you can see that apple is falling from the tree. So first apple was on the tree and after some time it is on the earth. So we can say that apple is also changing its position. Let us see the types of translatory motion. First is the rectilinear motion. If a body moves in a straight line, it is called the rectilinear motion. You can see the pictures below. You can see the cars are all are in a straight line. They are moving in a straight line. So we can say that they are a rectilinear motion. The person walking, running, a bicycle riding boy moving in a straight path are having the rectilinear motion. And the second one is the curvilinear motion. You can see the car is moving on a road which is a curved, which is not a straight in shape but having some curvature measurement. So we can say that car is moving in a curved path and which is called as a curvilinear motion. Circular motion. You can see the beautiful picture here. What you can observe here? All the boys and girls riding on an object is said to be in motion when it is moved around a fixed point called an axis. You can see there is an axis and all boys and girls are rotating around a single point which is called a circular motion. You can see the types of circular motion. First, which is called the revolution, and second, which is called the rotation. The first is revolution. You can see that a picture of sun and the earth just taking around the sun. So we can say when a body as a whole moves a circular path, its motion is called the revolution and the body is said to be revolve. Second, the rotation. When a body undergoes the translatory motion in such a way that its part covered a different distance in given time is said to be a rotatory motion. You can see that earth is rotating around its axis. The girl dancing is rotating around its feet, and see there is a windmill. Wings of the windmills are rotating around an axis. You can find similar examples in your home and your outside. Please list down the such rotatory motion and kindly note all these things in your notebook. Another type of motions are said as an oscillatory motion. When a body is moved to and fro about a fixed point, which is said to be an oscillatory movement. You can see that the hands of the clock, which is continuously moving to and fro, which is also a oscillatory motion. Also you are finding a swing. You are moving to and fro about a single point. so it is an oscillatory motion. Other motion is a vibratory motion. Sometimes the whole body of the object does not show to and fro motion, but the part of it shows the motion, and such motion is called the vibratory motion. This motion is actually very fast to and fro motion. See, there is a picture of the guitar and all strings are tied on both ends. When you vibrate the strings of the guitar, its both ends are remain stationary, but the part in the middle are moving to and fro and create a beautiful tone, and we can say that it is a vibration. In the chapter in standard 8 you had studied about the sound. So all the musical instruments like tabla, dolak, guitar, they all are providing you the vibratory motion, vibration of the object. And during this motion, a change in the shape and size take place. Let us see how to describe a motion. Suppose when someone will ask you that where your home is, or someone will ask about the address of your home or your school, you are describing that my school is located 10 km from the railway station, or you can say that my home is near to the railway station, my home is near to the bus station, or my home is at somewhere at Dudhya Tadav. So in every case what you are describing, you are describing the location of your home, your school, with some point like station, Dudhya Tadav, bus station. They all are called as a reference point. Let us assume that a school in the village is 2 km north of the railway station. Then what is that? Your school is located 2 km from north of railway station. So that north of railway station indicating that the school with reference to the railway station. We have to specify the position of the school with respect to some location, and that location is defined as a reference point. In the case the railway station is a reference point, we could also choose the reference point according to our convenience. Suppose you are asked where your school is, so you can define my school is 2 km from railway station, but how far it is from your home? So you can say that the school is 5 kilometers from my home. So when the reference point changes, the distance is also changes, and therefore to describe the position of the object we need to specify the reference point, which is also called as an origin. Let us see the motion along the straight line. The simplest type of motion is the motion along the straight line. We in this class first learn to describe it by example. See the figure below. Consider the motion of the object along the straight path. The object starts its journey from point O, which is treated as a reference point left of the figure. Let A, B and C represent the position of the object at different time instant. The distance given in the figure is in terms of kilometer. At the first, the object is moves through C, B and will reaches to A. N. Then it moves back along the same path and reaches C through B. What you can observe here, so first this object is traveling from O to A and the distance covered is 60 kilometers. N, on the backward path it is traveling from A to C, which is 35 kilometer. So the total path length covered by the object is O to A plus A to C. So we can say that object has traveled the total distance of 60 kilometers plus 35 kilometers. The total distance traveled is 95 kilometers. So we can say that this is the distance covered by the object. To describe the distance, we need to specify only numerical value and not the direction of the motion. These are the certain quantities which we describe by specifying only numerical value. So we can see that the numerical value of any physical quantity is its magnitude. And from this example, you can find out the distance of the final position C of the object from the initial position. What is the final position? That the distance between O to C, and that is only 25 kilometer. So this is the shortest distance between O to C. See, the difference will give you the numerical value of the displacement of the object from O to C, and that is only 25 kilometer. But the object has traveled the total distance of 95 kilometer, that is from O to A and A to C. But the object is only displaced from O to C. So we can say it is the shortest distance between O to C, and that is only 25 kilometer. So we can define it as a displacement. So what is displacement? The shortest distance measured from the initial point to the final position of the object is known as a displacement. Suppose you are moving from home to the school and from school to your home. So your total distance covered, say it is 5 kilometer, but your total displacement will be 0. So this is the motion along the straight line. Can the magnitude of the displacement be equal to the distance traveled by the object? Please answer this question. Yes, it is. When the object is moving in a straight path, in that case, the total distance traveled is equal to the displacement of the object. Consider an example given in the figure. For the motion of the object from point O to A, and the distance covered is 60 km, and the magnitude of the displacement is also 60 km. Now during the motion from O to A and back to B, the total distance covered is 85 km, but the distance from O to B is only 35 km. So your displacement is 35 km, but the distance traveled is 85 km. So the displacements are used to describe the overall motion of an object and to locate its final position with respect to its reference to its initial point at a given time. Let us find about the two different types of motion: uniform motion and non-uniform motion. Consider an object moving along the straight line. Let it travel 50 km in first hour. It travel more 50 km in second hour, 50 km in third hour, and 50 km in fourth hour. In this case, the object covered 50 km in each hour. So, we can say that object is traveling 50 km per hour. So, as the object cover equal distance in equal time interval, it is said to be in a uniform motion. The time interval in this motion may be small or big. In our day-to-day life, we can come across the motion where the object cover the unequal distance in equal interval of time. For an example, when a car is moving on a crowded street or a person is jogging in a park, these are the some different phenomena of the non-uniform motion, because sometime while driving a car you have to apply the brake, and that's how your speed is changing. So your distance covered with respect to time is different, so it is called as a non-uniform motion. Here are some differences between uniform motion and non-uniform motion. Uniform motion: movement of a body along the straight line with steady speed, which is called the uniform motion. But the movement of the object along the straight line with variable speed, which is called the non-uniform motion. In uniform motion, the object covers the equal distance in equal time interval, but in non-uniform motion, the object covers the unequal distance in equal time interval. For uniform motion, the average speed is similar to the actual speed of the object, but in non-uniform motion, the average speed is different from the actual speed of the object. If we draw the graph of distance versus time, it shows the straight line. The rectilinear motion has the zero acceleration. The distance time graph shows the curved and rectilinear motion has a zero acceleration. Measuring the rate of motion. You can measure the rate of motion. When we are measuring the motion, we are measuring it with respect to time, because time is an important part while measuring something. Different object may take different amount of time to cover the distance. Some of them move fast and some of them moves slowly. So we are measuring the distance covered with respect to time. The time rate at which the object moves can be different. Also, different object can move at a same rate. So we can define that one of the measuring the rate of motion of an object to find out the distance traveled by the object in unit time. The quantity is referred to as a speed. The SI unit of the speed is meter per second. This is represented by the symbol meter second raised to minus 1, or we can write meter per second. The another units of speed includes centimeter per second, or in a large manner we can describe the speed in kilometer per hour. To specify the speed of an object, we require only its magnitude, not its direction. We will later on see the velocity, which requires redirection. The speed of the object need not to be constant. In most of the cases, the object will be in a non-uniform motion, and therefore we have to describe or we have to define the average speed. We describe the rate of motion such an object in terms of average speed. The average speed of an object is obtained by dividing the total distance traveled by the total time taken. So, the equation shows you the average speed. Average speed is equal to total distance traveled divided by total time taken. We give the symbols V for an average speed, S for the total distance traveled, and T for the total time taken. So we can write V is equal to S divided by T will give you the average speed. Now, here are some activity that you have to do in your notebook for your reference. First of all, you try to find out the objects around you which are rest and in motion and list the type of the motion it has. Second activity that you have to do, that you have to take a scale and measure the different distances in your home. Third activity, try to walk from one end to another end in your room and find out the distance traveled by you. Note your displacement for the different cases. Find the distance from Navsari to Surat. Also find the distances from different cities from Navsari and try to note down in your books. If you traveled from Surat, find the distance traveled and displacement. If you are traveling from Navsari to Surat and back to Navsari, then find out your distance traveled and displacement. Ask the difference between odometer and speedometer which is on your vehicle, which is fitted on your vehicle like scooter, four-wheeler, and what that functions odometer and what is the function of speedometer. Please make in your notebook and we'll see in the classroom when we will meet. Thank you.